Okay, everyone. We are going to get we're going to get started here, and just so everyone knows, we will be recording the session. It will be made available later. So if you're trying to jot down notes or take screenshots, please note that everything will be, of course, made available to you. My name is John. I am Director of Additive Technology here at Javelin Technologies, and we're here today to just have a look at some of the new materials and maybe a look back at some of the other materials and what we can do with them on a more advanced basis. We really want to cover three things. So we're sort of targeting maybe 3 15-minute sessions to get through each of the topics, but some of them could be a little bit longer or shorter. The first one we want to cover off is preparing and printing FDM nylon parts. What are some tips for using Insight and maybe post-processing the part after you've printed it out? The other one, the art of finishing PolyJet clear materials. We can produce some very beautiful clear parts, but there are some steps that we can take to just get the best results out of those materials. And then last but not least, maybe you've had a chance to investigate this already, but there's a new soluble support material available for our PolyJet line of products. And that's very exciting in terms of reducing the labor component of processing parts after they've been printed. So in a second, I'm going to introduce our guest speaker. Just before I do, I just want to note that if you've got any questions, everybody is in mute mode, just to keep the noise down on the webinar. But you'll see a questions area. So if you've got any questions, please type them into the questions area, and we'll be happy to address the questions at the end of the webinar. So without further ado, I am very happy to have Ken Burns, who's the materials manager from Stratasys, here with us. So without further ado, let's turn it over to Ken. And Ken, just after we flip things over, maybe you could give us a brief introduction.
Great, thank you, John. As you said, the title here is Beyond the Basics with FDM and PolyJet. A little bit on myself. My background is I've been working in the additive manufacturing industry for about 6.5 years now. Prior to coming on board at Stratasys, I worked for a couple of service bureaus, one of which was actually the first one to purchase a Connex system. So I have a lot of background with the PolyJet technology, and we also owned a handful of FDM systems, SLA, Z-Corp, and SLS. So in my tenure at those positions, I was able to get a lot of hands-on experience. I've done pretty much everything in the operations of additive manufacturing and 3D printing, from file preparation, modification, printing, cleaning, all the way through finishing. So hopefully that kind of helps with some of my background here and where I can come in and hopefully give some good tips and guidance to just going beyond the basics with some of these processes and materials. So like John said, we're looking at 3 sections here. I'm going to start on FDM Nylon 12, going to VeroClear finishing, and then finish up with PolyJet soluble support, and then we'll have some time for a Q&A at the end. So we want to start with FDM Nylon 12 today. When this material was first released, we had a lot of pushback just with customers not understanding how to run it well. This material is different than our standard FDM materials, and so since that time, we've actually come out with a lot more tips and tricks and processing to ensure that you get the quality parts that you're used to with our other FDM materials. So to begin, we want to just kind of cover briefly what is nylon. It is one of the most commonly used thermoplastics in the world. Nylons are called polyamides and are available in several common grades. As shown, you can see over here we have examples of nylon 6/6, nylon 6, nylon 11, and so on. And nylons are readily accepted fillers, which add strength and dimensional stability when blended with the base polymer. So common ones are aluminum, glass, carbon. And then finally, nylon 12 in particular is better than most nylons in chemical resistance. So for the FDM system, this is where we started with the nylon 12, just to get us a good base material with great chemical resistance, which we'll be discussing today. Our first section is going to be on printing recommendation tips. So on the screen here, you can see our nylon 12 quick reference guide. This is available and is a great tool to have when running Nylon 12. If you don't have a copy of this, please contact Stratasys or Javelin and we can ensure that you get a copy of this. So there's 4 sections here. The first section, evaluate tip wipe assembly. Second section is proper build mode. The third is removing your parts from the printer. And the fourth is proper tank temperature. I'm going to go more in depth on these sections here as we move along through the presentation. But again, just wanted to make sure you're aware that we have this guide available. That's nice to have handy when you're running parts. So first we're going to start with tip selection. Tip selection for Nylon 12 is important and will vary based upon the requirements of your application. The smaller slice heights provide better aesthetics and surface finish, while the larger slice heights can improve strength and toughness. Currently, Nylon 12 is available in 7, 10, and 13 thousandths inch slice heights. So it's important to check and set the tip wipe assembly to the proper position and ensure tip wipes are clean. Tip wipe assembly maintenance and adding a sacrificial tower also improves part aesthetics. So you can see in the images there a good tip in with displayed bristles on it when they definitely need to be replaced. We're going to briefly discuss some build modes, but I'm going to go more in depth on this in the insight consideration section. Proper build mode selection prevents warping or melting of thin and thick walls. Geometry-specific build modes enable optimization of part quality and mechanical properties. For example, parts with multiple thicknesses, you should use the thickest wall size, stabilize thin features, and point them into the airflow. Our software will automatically adjust the oven temperature to control the crystallization rate and reduces internal stresses. You can see in the table down there on the right the build mode, and then the typical wall thickness or the thinnest wall that you should be referring to when building these parts. Part orientation is also an important consideration with Nylon 12, and perhaps probably the most important consideration versus other materials. The example in the picture is a Nylon 12 part built with typical parameters to minimize support and build times. As you can see, the part has a rough surface quality. The images on this slide are of the same part but with much improved surface quality. To optimize part quality, it may be necessary to orient parts at an angle. Smaller surfaces, approximately 1 cubic centimeter, are less affected by part orientation. When determining your applications, you may need to compromise between surface quality and build time and consumption. So again, the emphasis here is just that this Nylon 12 parts can't necessarily use the same parameters to save on build time and material consumption, as you will sacrifice a lot more with your part quality. It's also good to note that this could take some experimenting on the user's end to understand the best orientation for the part. And so we encourage customers to not give up if a part builds unsuccessful on the first try, but to understand that there's different parameters that may be required. So on the build sheets, proper storage and usage of the build sheets for Nylon 12 is important as they are moisture sensitive. The dry build sheets will draw down on the vacuum plate much faster. Simple practices such as only opening the sheet package from one end and remembering to fold close the package when done will help prevent moisture absorption from the surrounding environment. Again, this is a small step in the process, but does have a big impact on the part quality. So I think I might be a little off on the slide there, so let me know if I was missing one of those. Next, we're going to look at porosity. Porosity of the part, we'll go into a little more on the toolpath variables and insight consideration sections as well, but to briefly touch on it here, we'll go over a couple factors. So looking at the part fill style and the contour width, multiple contours can be used to hide raster turnarounds and enhance aesthetics. You can adjust the contour to raster air gap to create a more aesthetically pleasing part as well. Recommendations of in millimeters are listed there as well. Then finally, using a positive air gap, 1,000ths to 3,000ths of an inch to improve aesthetics. The raster to air gap creates a slight overfill of the part, and this can increase its strength as well, in addition to the aesthetics. A common practice with FDM parts is include a sacrificial tower. And this is something that's recommended with pretty much all FDM materials. This is especially important when printing with nylon 12, as this improves the seams and part quality. This is a simple feature in the control center where you can just include a sacrificial tower, as you can see on the screen. So the support removal process is very important for nylon 12, as this can make the difference between successful and unsuccessful parts. So as we've gone through the whole printing process and you have good parts, the next step is removing the support, which again I want to emphasize how important this is, because you could lose a successful build just with the support removal side. So the first one to remember is to not skip the conditioning step, which is a minimum of 4 hours in the waterworks solution. Parts will not perform well without it, as this step maximizes mechanical properties and dimensional accuracy. Second, do not remove support material manually. The support material actually has a chemical bond with the model material. It must be completely removed in a chemical bath to dissolve all of it. Attempting to break away could damage those parts. To break away support could damage the parts. Ensure all support is removed. Remaining support material can cause brittle parts. And then finally, keep your tanks clean. A high concentration of dissolved solids can absorb into the part and cause brittleness. So again, missing any of these steps won't necessarily completely deteriorate your part, but it can lessen all the mechanical benefits of the nylon 12. Proper tank mode selection prevents warping or melting of thin, thick-walled parts, while also balancing support removal time. The chart in this slide provides a quick reference for the oven temperature depending on the wall thickness of your parts. Next, we're going to jump into a few insight considerations. So starting here with build mode. Selecting the correct build mode can impact your part quality. While most parts will use the standard normal setting, the system mode can be changed to account for thin or thick-walled parts. You should choose the build mode based upon the thickest section of the part. For parts with a wide variation of wall thicknesses, you can build the part at an angle to improve part accuracy. So here, just noting that this is using a combination of build modes and angle of the parts to understand the best settings for your geometry. We're going to take a look at the interior toolpaths and multiple contours. Modifying the toolpath parameters can improve your part quality. You should avoid multiple contours when it is not required. However, you can use multiple contours to hide raster turnaround for improved aesthetics. I want to make an emphasis here. Remember, the only purpose to hide raster turnarounds is for improved aesthetics, though. So again, something you need to consider. You're looking for the best aesthetics of a part or best performance of a part. FDM Nylon 12 has better inherent properties for tapping holes as well, and we recommend internal rasters for this process. It doesn't benefit as much from multiple contours like other materials. For FDM Nylon 12, the contour to raster toolpath tends to create a stronger part. To create a better aesthetic part, the contour to raster air gap can be adjusted to a more positive air gap of plus 0.001. This slightly reduces, let me emphasize here, this should be noted, this slightly reduces the elongation of break, the sealing properties of the part, and reduces the overall strength by 5 to 10%. So again, we're choosing here between aesthetics and some of the mechanical properties you might sacrifice on. The default value from the raster to air gap creates a slight overfill and increased strength. So to utilize this, use a positive air gap to improve the aesthetics, 1,000ths to 3,000ths of an inch. And again, as in the former slide, this slightly reduces the elongation of break, sealing properties of the part, and the overall strength by 5 to 10%. When using enhanced mode, use a positive 0.5 to 1/1000th of an inch for improving aesthetics. So again, these last couple slides are focusing on how to improve the aesthetics of a part in nylon 12. By adjusting the part raster width, you can also impact the part success. Wider contours and/or raster tool paths allow more surface-to-surface contact and can help increase strength. Parts may have a slight overfill as a result of this. Using the model for support feature in Insight to decrease build time may cause supports to bond with model. So as you can see here, we're recommending to use the model material where possible within the support parameters. The natural overfill qualities of nylon 12 may cause heavy seams on corners since spacing between model and support is minimal. If the model for support feature is used and material overflows on corners or seams, it may fuse with the actual model itself. I know there's a lot of slides there with a lot of images from Insight. So again, this is something that will be sent out after the presentation, so you can have a reference of where to refer to on those Insight considerations. Next, we want to take a look at a post-process of annealing capabilities with the nylon 12. So as we mentioned at the beginning of the presentation, FDM Nylon 12 is the first semi-crystalline FDM material. The benefit of this process of annealing can increase the degree of crystallinity, impacting the thermal and mechanical properties. It's important to note that annealing is not required if your parts are not going to exceed 50 degrees Celsius. So this step can be completely removed. This is only for above 50 degrees Celsius. Once again, we have recommended parameters for the shrink factor based on the tip size that is used as well, and that's in the table in the top right-hand corner. If you are annealing parts, it is recommended to support them in a bed of aluminum, sand, or similar. Aluminum is a good conductor of heat and keeps the temperature consistent around the part, reducing the likelihood of them warping during this process. Once again, the chart in the bottom corner displays the recommended temperatures for the oven based upon the part geometry. So you can take and just understand if your part has thin walls, thick walls, or it's a brick, you can see what to set the oven at for annealing. The part should also be annealed prior to removing the support material. So to close out the nylon 12 section here, we just have a couple of videos demonstrating the impact of this material and what it can actually achieve. So the first video here I'm showing is just a high elongation of break. It's noted too, there is no sound with these videos, so don't feel like you need to turn something up here. Okay, and then the second video is going to show the high impact resistance of nylon 12. Great, so before we move on to the next section, I'd just like to note there are more tips that go along with an Insight to consider for this. I kind of pared down this presentation to just highlight the main factors on here. But if you're still experiencing issues or you want more success or to better understand what can be done, definitely contact Javelin or Stratasys and we can get you more information on how to be successful with building in nylon 12. And from personal experience, I know this is a fantastic material. As you saw in the presentation, it does require a little bit different parameters to really dial it in and be up at the same par as other FDM materials. So next we're going to jump into VeroClear finishing and how to truly achieve the translucent or transparent parts. So a little bit on VeroClear. Properties of this material is translucent. It does have true transparency. It's PMMA visual simulation, great dimensional stability and durable parts, excellent surface finish, and great fine details appearance, similar to the rest of the Vero family. This is currently available on Object 30 Pro, Object 30 Prime, the Eden family, and the Connex family. So VeroClear is ideal for form and fit testing of clear or see-through parts. Examples are glass, eyewear, lighting covers, and light cases. So it's a great job with visualization of liquid flow. The material is also great for dyeing, medical applications, and we've seen some good usage in artistic and exhibition modeling. Just in the images, you can see a few examples of it in works. In the bottom right there is the castle dyed blue, or greenish blue. So next we want to jump into some brief printing guidelines. So we have two examples here. One is a sample of the material right off the tray, and another is a sample after a few days. Nothing has been done to this model. So when removed from the build tray, the VeroClear models may have a slight yellow tint, which will fade over time. This is actually completely opposite of SLA, if you're familiar with VeroClear parts, which actually yellow over time. So I know a lot of times customers have concern when yellow comes off there that they only become more yellow, but the opposite is true here, in which they will actually become more clear over time. So here we have two more examples of a part. This sample is printed in our matte finish in high speed mode. So the sample on the left is right off the tray, and the sample on the right is after polishing and lacquering for 20 minutes. So a pretty quick amount of time, and we'll go more in depth on the exact process of how you achieve this throughout this presentation. So printing guidelines. First, we start with material replacement. When changing to VeroClear, as a ground rule, perform a high performance plus economy to achieve the best results. Cleaning printer components. We recommend you clean the print heads, wiper, and roller waste collector thoroughly before and after each use. Printing preferences. By default, you should use high-speed matte to reduce UV exposure, thereby improving clarity. So you can think of this, we kind of liken it to putting sunscreen on a part. It just protects it from too much UV exposure. We realize this isn't always possible when parts require the glossy finish, but in most cases, this is going to get you your best clarity. And then tray arrangement. So when printing parts in glossy, arrange them so they have similar heights to ensure they are not exposed to unnecessary UV radiation. So again, if glossy is necessary, try not to put a very large, tall part on there so the smaller parts are just being overexposed and will cause too much yellowing. The next process is photo bleaching, which is a post-process. So when removed from the build tray, the clear parts have a slight yellow, which will fade over time. You can greatly accelerate this process by using a suitable photo bleaching treatment. We have two suggested photo bleaching methods. The first is table lamps. This is a simple, self-assembled from available components you can find at most any hardware store. This is a low-cost solution. However, you do get varying results due to the lack of precise control over temperature and light intensity. The cost for something like this is approximately $50 to $200, depending on the number of lamps that are used. The second is an illumination chamber. These are off-the-shelf chambers that enable controlling the temperature light intensity, and these assure predictable results. A cost for some of these is typically around $1,300. And sorry, this is all in US dollars. So what are the effects of photo bleaching? After 6 hours, we can already see a 70% improvement in clarity. After 24 hours, we see about a 90% improvement in clarity. Anything over 24 hours is pretty minor for improvement there. So our recommendation is typically let it sit for 24 hours in illumination chamber to get the maximum clarity out of the part. So here's an example of a part before treatment, photo bleaching in a chamber, and then photo bleaching with table lamps. So as you can see, the photo bleaching in the chamber exhibits the best results, which would be expected. So effects of photo bleaching. So this is the process if you're going to do it yourself, what you need to do. So first step is to cover the inside of a container with aluminum foil, as this is a good reflector of light. Arrange the printed models in the container with enough distance between them to allow light to reach all sides of each model. Prepare 2 table lamps with 45-watt, 6500 fluorescent lamps. Position the lamps on the table approximately 10 centimeters or 4 inches above the model. This distance prevents the lamps from warming the models above 40 degrees C or 104 F, which is the heat deflection temperature of Vero. And then after 6 hours, inspect the models. If the results are not satisfactory, leave the models in the chamber for up to 18 hours more. So again, we're aiming for that 24-hour time frame. So next we're going to look at polishing to improve the clarity of the parts. Polishing can create smooth and clear surfaces by sanding it. This is done mostly when transparent parts are required. Polishing makes truly clear models a reality. And typically, lacquering is also done to improve the clarity of the part. So here we have an example of a part on the left, which is off the printer, and then one that's been sanded. So right after printing, and then after polishing and lacquering, and you can see the dramatic difference in the clarity. So how do you polish? So to prepare the model, thoroughly clean the printed model using water jet to remove the poor material. Dry sand surfaces. So we're starting with the dry sand here to remove all the lines and steps and thoroughly dry the model. Sand with 200 grit sandpaper, and then repeat the process with a 320 grit sandpaper. Next, we're going to want to do a wet sand. So lightly wet sand the model, progressing through 400, 600, and 1,000 grit. Between each sanding, rinse the model with water to remove any grit and debris. Next, we'll go with the micro mesh sanding. This is an optional process. For an exceptional finish, polish the model with micro mesh sandpaper, 1,500, 1,800, 2,400, 3,600, and 4,000. And we do recommend using a soapy water solution. Polishing, for best results, use polishing compound. If possible, use a buffing wheel or a rotary wheel for the buffing drum. But again, that's not necessary. After polishing, use a soft cloth or buffing pad to shine your model. And just a quick note there that loss of material during polishing is around 0.1 to 0.3 millimeters. So the dimensional accuracy is critical here. You want to make sure that's added for in the model prior to printing. And again, I want to emphasize on these 6 steps here, not all of them are necessary to get the clarity. It just depends on what clarity is necessary. So we recommend just kind of going through the phases there, and you can find where you end up for that specific model or application of how clear it needs to be. Here we have an example of a part printed off the printer on the left here. And then this is after it's actually gone through everything. So it's been wet sanded, polished, and everything to the very end there. And you can see looks pretty much like a crystal ball with the part inside of it. So next we have a short video here. Again, there is no sound, there's some music in the background, but just to kind of show you the time and work that it takes to go through finishing a clear part. Hopefully that helps. Just give a quick example of the finishing process there. Obviously, that was a flat part, so it's much easier to sand and polish than parts with more geometry or curves in them. But those can also be achieved. And so some minimal effort can definitely increase the clarity on a part specifically, and then with going through the entire process, you can get some fantastic glass clear parts on there. Great, next we're going to jump into our PolyJet soluble support material. So the new support called SUP 706 was officially launched on November 17th, so just a couple of weeks ago. This was purely a launch date, not a release date of the material. So the material is currently going to be released for customers to purchase. However, it is in a little bit slower process because it does require an on-site upgrade to the system. So it won't just be as simple as purchasing the material and plugging it in. And if you're curious of how to get that, just contact Javelin or Stratasys to get in line to update this on your system. So the new PolyJet soluble support material truly does enable hands-free, high-volume 3D printing within our systems now. So we have freedom to design intricate, multi-material parts that can be easily cleaned, a simple soak and rinse process that enables hands-free support renewal, significant improved print process productivity. This is currently available on all Stratus 1, 2, and 3 on the 263 V500 printers. So for the initial release, just on the Stratasys Connex 1, 2, and 3 systems. So like I said, true hands-free support removal. I'll take a minute to kind of expand on this. We envision this as there's basically 3 options for removing the support material with this new material, which one would be the traditional process of utilizing the standard water jet and drying process. The material itself is softer, so it does remove, it is an easier remove option than the current support material, even if you're going to stick with the same process. The second we envision as a combination process, where customers will break away from the larger supports and then let the remaining soak off. And then finally, the third process would just be completely hands-free of just throwing parts in a cleaning tank and letting them soak off. The times for these vary upon part geometry, as you can imagine how much support is on there. But we see most parts always within 24 hours, and then the majority of parts are 12 hours or less, which is kind of ideal for a print during the day, soak off during the night. And so small parts are easily cleaned. Fine, delicate details with internal cavities can now be designed and easily cleaned. You can optimize model support design in these. And this does work well with all PolyJet materials. Our previous Connex or Unit 260V was only available with select materials. This is available for all of our PolyJet materials. It should be similar price as current support, but with much better performance. We've seen some of our earlier tests increase performance from 50 to 80% reduction in labor. And then there's an alkaline cleaning solution, which is long-lasting. It's about 1.5 months or 6 weeks between refreshes. And this is a simple preparation and neutralization before disposal. This does require a cleaning tank if you're utilizing this to put the solution in. We will be selling the cleaning tanks as well. There is no heat in these tanks, but there is agitation to help improve the process. This is not necessary, but it's just is how we envision maximizing the support removal. The next one here, we have 3 samples of where we see this impacting the applications out there. So the first is a cologne bottle, but we don't want to get caught up on a cologne bottle being the actual application, but rather what it does. And so there's complex cavities here with a sophisticated design and it's utilizing multiple materials. So typically in the past to clean a part like this, you probably would have to cut it and then create a seam on there, which is not ideal for a clear part to have a seam line going around it. And now you can have just a small hole at the end of this, and we're able to dissolve out the rest of the material inside of it. The second is a fluidic channel model. So creating a part with complex channels, cleaning the inner cavities is very simple now, and then you can do a fluid analysis of this. So this part may have been able to be cleaned with the current support using some wires and other tools to get in there and actually scrape out the material and push it out. However, you're likely going to be left with some support material inside of the part, as it would be almost impossible to remove all of it. And now you can get it completely cleaned out of there just with the dissolve. And then finally is our mesh cube. Well, the mesh cube is not really an application that you're likely going to print and utilize for something. It gives an example of some complex geometries and finely detailed parts. So you could print this part with the current support, and you would probably break a lot of the inner walls there trying to remove the support, if you could even get it all out of there. And now this can be completely achieved without any additional fear of damaging parts. And so this one is a good example of how if you have printing lots of parts, maybe 100 small parts with some thin walls on there, and you typically, maybe you print an extra 50 or something just because you know you're going to end up damaging or breaking them. Now you could actually just throw this all into the tank, let it dissolve off, and then be ready to go. Great, that covers all of our topics today. We'll take on some questions here, and I'll go from there. Thank you for your time.
And that was great. I learned a few things along the way there too. I think you might have done a little too good of a job. I don't see any questions in the question area, so maybe we'll just hold for a few minutes and see if anybody wants to type a few in. Actually, maybe I'll go first. Maybe you know this one. It's one that I get all the time. I think we recommended, or you recommended, to print the clear parts in a matte finish, which really helps with the clarity. I know what you're talking about from some of the work we've done here. But is the finishing process, from your experience, the same whether it's printed in gloss or in matte?
It should be the same either way on there. Yeah, some customers, what I've learned, it comes down to personal preference on this. Some customers prefer to finish clear with a glossy finish. Some prefer the matte finish on there. It's kind of just what they become used to, or their finishers have become used on there. But at the base level, it should be the same process for either glossy or matte.
Yeah, great. You must have done too good of a job because there's still no questions coming in. So what we'll do, folks who are still hanging with us on the call, thanks very much for your time today. Hopefully the information that Ken shared was of value. And Ken, if you will, we'd love to have you back to maybe cover off some other topics in the future. We will reach out to all the attendees. So if you've got some, oh, hold on, we've got another call coming in. Is that the same with, is the finishing process the same with soluble support?
Everything is going to be the same with soluble support. We don't envision any changes to any of the finishing. I'm assuming they're talking about VeroClear parts, or if they're talking about parts in general. VeroClear, yes, same. With the soluble support on general finishing, no impact. And again, we actually envision this being easier since it's going to be dissolved out. I think a lot of times with the current support material, one of the things we see from customers is that some of the material can actually get somewhat embedded in between the layers there, because even though we're printing at a very high resolution, the material can still get stuck in there, so some customers complain that it's not completely removed. With this new one, it will completely dissolve out.
Great. There's another, I'll take this one because I know the answer. Can we get a PDF copy of the very nice presentation? And for sure. So for those of you who have been on the call, we will be sending out, if not the PDF directly, at least a link to it, so that you can download it and have it for future use. So I think with that, we'll call it an afternoon and let everybody get back to their day. Thanks again, everyone. Take care.
Thank you.